Hello, everyone. Once again, I managed to remember to unmute myself before I start talking. So this is 2 in a row. I don't know what is happening. Joking, of course. Thank you all for staying with us this whole day. And we are coming very soon to the last talk for this day. But we are going to have a program tomorrow as well. I would like to thank Lucija Markovic from Poslovna inteligencija for joining us. She's going to talk about data privacy management as part of our transformational AI part of the track. Lucija is currently working as machine learning researcher at Poslovna inteligencija, which is also one of our closest partners in Croatia. Right now, they're working on developing software that could solve one of today's potentially unsolvable problems. Basically, when we are talking about data privacy, we are talking in one hand about security, but on the other hand about misuse of personal information through data collection. The idea is to make an AI that will be able to find, classify, understand, and collect personal data, thereby speeding up the personal data life cycle, which can be very, very slow. The end goal is to help companies to be more efficient and prevent misuse of personal information. Like I said, I welcome Lucija to this stream, and Lucija, you have a mic. Let's say you have the floor.
Thank you. Hi, welcome everyone, and I'm glad to present you what we have been doing with machine learning on data privacy for last year. So today I'm going to talk about Data Privacy Manager and our classifier models for unstructured data. So a little bit about Data Privacy Manager. We are actually a startup under Poslovna inteligencija. And Data Privacy Manager is a software platform that is being developed by a team of privacy and technology experts. And our aim is global positioning in the field of data privacy protection. First version of our product was released in 2017, and since then we have been growing as well as our team, as our market share. We cover different aspects of privacy regulations and information security, and we are listed among top 15 software providers for data privacy in the Forrester Wave. So today we will cover topics of what is data privacy and some regulation and acts and why we are doing all of this. Then we will talk about machine learning for textual data and the model that we have developed for named entity recognition. So what is data privacy and why it's important? Data privacy or information privacy is part of data protection area that deals with proper handling of data while focusing on compliance with the data protection regulations. Data privacy is centered around how data should be collected, stored, managed, shared, and shared with third parties, as well as compliance with applicable privacy laws such as California Consumer Privacy Act or General Data Protection Regulation (GDPR). So data privacy is not just about proper handling of the data, but it is also about public expectation of privacy, and it is centered around individual as a key figure. There are three elements of data privacy. One is the right of individual to be left alone and have control over their personal data. Another element are the procedures for proper handling, processing, collecting, and sharing of personal data, and the compliance with data protection laws such as GDPR. Why is data privacy important? Data protection laws around the world have given back individuals the control over the data. They have allowed them to know how their data is being used, by whom, and why, and it is giving them control on how their data is being processed and used. So the organizations need to know how to process personal data while protecting privacy preferences of individuals. And that is what individuals expect from organizations, and it is part of the vision of the privacy. For a business perspective, protecting personal data and putting the emphasis on data privacy can have multiple positive impacts on the organization, such as meeting the customers' expectations, to achieving competitive advantages in form of higher quality of data, improved customer experience, and greater investor appeal and brand. Another thing that is needed to be said is that the data privacy is not the same as data security. And to properly protect your data and comply with data protection laws, you need both data privacy and data security. So the data privacy focuses on the rights of individuals, the purpose of data collection and processing, privacy preferences, and the way organizations govern personal data of data subjects. So it focuses on collection processes, sharing, archiving, and deleting the data in accordance to the law, while data security provides the standards and different safeguards and measures that an organization is taking in order to prevent third parties from accessing the data and using it in malicious attacks or exploitation of stolen data. Both are really important for the organization, and the privacy cannot exist without security. Privacy has also been recognized by governments worldwide, and it resulted in multiple data protection laws. GDPR is not the first privacy law, but many privacy laws before GDPR were outdated. And as we know that the technology and the way we communicate has really changed recently, so there is more data out there that needs to be regulated. General data protection regulation marketed the first serious intent to control the excessive exploitation of personal data, and they are first to define both data processors and data controllers appropriately. And it has given the subjects the power to regain control over their privacy. After GDPR, US Congress passed similar laws, and soon were more to follow. So in the years to come, data protection laws will continue to evolve, as will data privacy. And organizations should take this into consideration when creating their their business plans and strategy and marketing activities. Not only because of the fines, which we can see are enormous, but because it is what individuals expect from them. So companies will need to be able to demonstrate compliance and show transparency in the way they handle the data. And how you can achieve that faster? Well, that is why we developed data privacy software, which could help you achieve and demonstrate compliance by automating data privacy principles. And that is why soon there will be another feature in our software that will also help with discovery and classification of personal data in more advanced way. So one of the question is, where is all that data that needs to be classified and protected? So there is a lot of dark data in our systems, and dark data refers to data that was collected, processed, and stored by an organization during the regular course of business, but it hasn't been analyzed. And each day there is 6.7 sextillion gigabytes of dark data that go dark, and that data is also referred to as unstructured data or dusty data. And that is something that we need to regulate and find and know how to handle. So why is there so much dark data out there? Well, with structured data, machines can easily understand it, but humans have hard time reading and understanding structured data. So, and humans use unstructured data to communicate, and that human accessibility makes it difficult for machines and algorithms to access and analyze unstructured data. There is unstructured data in the text files we exchange every day, in images, in video files, calls, emails, and so on. And that is something that we need to focus on. And we need to discover that dark data. The data discovery is a process of scanning through a large amount of unstructured or dark data to get a complete inventory of what is in our organization. And it helps the organization to segregate relevant, necessary, and actionable data. And organizations need to have clear understanding what is in the data they possess. And something that organizations usually find difficult is how to manage dark data, because it is stored across distributed IT environment and there is no single owner of the data. So the dark data needs to be examined to see whether it holds any relevant information, or and we need to be able to capture personal information in it. Some of the challenges we need to solve is know where is the data, identify who has access to it, determine who uses it and for what, track it, define how to manage it, protect it, and destroy it if needed. And this is what our data privacy manager software can help everybody achieve. And that is why we are developing our ML model for personal data discovery. Right now, we are focused on text data, which is one of the most common types of unstructured data. So any files, documents, contracts, emails, and CVs. And that is what we are going to talk about now. So why are we using machine learning? Why not just a regular expression for information extraction? Well, regular expressions are easier to use, but at the same time, they will not be able to cover everything we need, especially if the text is not structured in the way we expect it at all the time. So what we would do then is we would need to update the regular expression every time we miss something. So in this case, we can parse Australian address, but we wouldn't be able to do it for European or American, but we would need to adjust our regular expression. With machine learning, we can label our data and make the model learn it, and it would be able to generalize on other texts as well. But if you go for machine learning approach, then you will need a lot of data to train your models on. And that is something that we have collected and did as well. So instead of relying on machine learning, on regular expressions, we use machine learning text classification. What it does, it learns to make classifications based on past approaches by using pre-labeled examples of trained data. So machine learning algorithms can learn different associations between pieces of text. So let's say for the particular tag of a name, if we see expected input John in this case, we will know that that tag is the tag for that part of text is name. And the first step in training a machine learning model for natural language processing is feature extraction, that is vectorization. So we need to transform our text into a numerical representation of in form of a vector. Why? Because machines cannot read words. So one of the approaches that could be used is document vectorizations, such as bag of words or TF-IDF. But we cannot use that because it doesn't retain the word order, which is needed for our information extraction. Another approach is one-hot encoding, but what that leaves us with is very large and very sparse inputs. So in our case, the best approach is the embedding layer. So we are using word embeddings, and word embeddings are the type of word representation that allows words with similar meaning to have similar representations. They are a distributed representation for text, and they are what allows impressive performance of deep learning methods on challenging natural language processing problems. So an embedding layer is the word embedding that is combined with the neural network model. We want to train a specific natural language processing task on, such as language modeling, document classification, or named entity recognition. Each word in our text is then one hot encoded, and the size of vector space is specified as a part of the model, such as 50, 100, or 300 dimensions. And the vectors are initialized with small random numbers, and then later the embedding layer is trained and fitted together with neural network by using propagation algorithm. And that embedding layer is a part of our named entity recognition model. Named entity recognition, that is sometimes also referred to as entity chunking, entity extraction, or entity identification, is the task of identifying and categorizing key information or entities in text, such as personal name, last name, location, organization, drug, biological protein, and so on. That entity can be any word or any series of words that are consistently referred to as same thing. So every detected entity is classified in predetermined category. For example, let's say that we have a DPM in a text, and then named entity recognition would classify it as an organization. That is what we are using that is our model that we are using on our on unstructured data, and that is what will help us find personal information in the dark data. So there are different approaches to named entity recognition. One is the knowledge-based system that requires lexicon and domain-specific knowledge. There are also unsupervised systems that require minimal training data, but they extract entities based from clustered groups or use corpus statistics. What we focused on the most are the feature engineered supervised system, such as conditional random fields and feature inferring neural network systems. And the most common combination in the last few years is the combination of neural network by LSTM and conditional random field that is used for sequence labeling architecture. Another crucial thing for a named entity recognition model is the corpus. So that the corpus contains a large amount of labeled sentences. We label entities we want to extract by using IOB tags. So I meaning the B meaning the beginning of entity, E inside of entity, and O outside of entity. Most out-of-the-box models are trained on billions of records, so that is something that you need to think about if you want to train your own models. There are some out-of-the-box solutions, the open source libraries that you could use for named entity recognition, such as NLTK, SPACY, LNNLP, or FLAIR. And there is also a lot of pre-labeled corpora that you could use to train and test your own NER models. But we are not using those because we are not using pre-labeled corpora or pre-trained models because we want to train information extraction model for a very niche area, personally identifiable information. So if we took some pre-labeled corpora, it didn't match our requirements. You can easily find corpora which has a location tagged in it, but we wanted a specific address. Also, for example, the date tag can contain centuries or periods, but we only wanted the exact dates in our model. So that's why we created our own corpus that has PII entities. It's been created by using open source texts, forms, and we used our own synthetic databases to fill in our data. We labeled over 200,000 words ourselves, and we created additional matcher algorithms for all the domains that didn't really need the complex neural network models. So about our model, as I have said, we are using embedding layer, but we are not using the classic word embeddings such as Glove or Word2Vec because the entities in our case are very dependent of the context of the sentence or on the context of the whole document. So, for example, in these two sentences, the word black has two completely different meanings. And if we use the regular classic word embedding, let's say that the word black would be a vector of zeros in both cases. And then we couldn't know the difference between them, and we couldn't use that successfully for our classifier. But if we use transformer word embeddings, such as BERT, we can get insight in the context of the word that is put in the sentence. So BERT stands for bidirectional encoder representations for transformers. And we are looking at both the words before the word of interest and after. And so in this case, we know that in the first sentence, the word black is for the color, and in the second sentence, it is for the race. And a race is something that we could need in the personal data that we could classify as personal data if needed. So as well as that embedding layer, we have two different approaches for the classifier. One is that on top of the embedding layer, so we use the transformer to generate embeddings for each word in a sentence. And then we use that as an input to the standard sequence labeling architecture, so the by LSTM conditional random field architecture. And the weights in the transformer, in this case, are frozen, and the training is limited only to the neural network. So this is one of the classic approaches in the last few years, and the benefit of it is that it is a well understood model, and it includes a real stopping criterion. Another model that we have found useful in our case is a fine-tuning approach, where we add a single layer on top of that transformer embedding, and then we fine-tune the whole entire architecture. This approach gives us really good results in the problematic domains, such as organizations, where you could have similar text as in a personal name or just a random combination of numbers and letters. And this approach gives us more better results because it looks more in the context of the whole document. But it takes a lot more time to train, and it uses a lot more resources. So, but for our first use case, we are very proud of our models because they work exceptionally well on the test data and some examples of the real documents that we will deal with. For most of our domains that we have looked into, we have F1 score for over 97%. And it works really well for person, address, organization, date, telephone, email, and so on. What that it means for Data Privacy Manager? Well, when we get the document that we want to discover, and then we want to discover which data is in it, and if it has any personal data, we can output which domains we can found in the document. We can tag spans where those entities are, such as this example here. And then Data Privacy Manager can decide what to do with the document, how to handle it, and even to mask personal data in it. Our ultimate goal with this is not just to stop here, but to link the data that we have found and to select the right person from a number of different data sources from both structured and unstructured data. And that is what we call named entity linking and disambiguation. So what it means is that we want to link personal data of the existing data subject, then query that for all possible candidates, and then probabilistically determine the best candidate or data subject from the finite set of possible candidates. And what is data loving DPM? It is allowing for a complete data linkage for any data source at any point in time for every data subject. So it is complete linkage between all of the data and complete discovery. With those systems, we will be able to remove problems that unstructured and dark data presents when it comes to data privacy. So that is it for the presentation, and we can have the Q&A now.
Hello, Lucia. Thank you very much for this inspiring talk. And it was very, very awesome to listen. For the first time, I need to say, I need to admit that I didn't listen before about Data Privacy Manager, though I spoke with Dražen a lot of time about it. But this is the first time I had the chance to listen. So basically, we have a few questions, and because it's the last session for today, I will maybe try to use 2 of them, and 2 of them maybe you can 3 of them to answer, and 2 of them you can maybe record a small after video by Friday, so we can post in our social networks as a follow-up. Okay. So first one, what is your stand on ethical design? It may not be data privacy, but it's connected with how the data is used. So basically, I think this is maybe related to your personal stand and not maybe the Poslovna inteligencija.
I think that is the question for how we use a lot of personal data in machine learning and data science. So that is something that we need to take into account of how to protect ourselves and also data subjects. Well, I think that is really important thing that we need to think about when doing anything with data that is personal.
Okay, thank you for that. The second question is, it's maybe a little bit more organizational. I will skip question 2, I will go to question 3. How hard can it be for an employee in an organization to follow the established procedure for data privacy What are the biggest issue here? And maybe this is where I think data privacy manager can help a lot, basically.
Yes, data privacy manager could help here a lot because it automates some of the things that usually data privacy officer needs to do. So it goes into the field of compliance and the whole 360 of data privacy. So there are multiple models in data privacy manager, and there are a lot of them that could be useful for an organization that does not have anything automated right now and has only a person that does all of the things.
Okay, and last question before we come to conclusion, I will send you the two remaining questions to the email. How big a vector matrix can become when using two-step process in practical use in some bigger company, let's say? When we are talking about vectorization, I think that this is connected to that question that you talk about. So how large, how big can become, how large can become vector matrix, and maybe this can also be related to the technology. How fast can it then run if there is some bigger?
Yes, they are. Well, as I said, we have two different models right now because one of the models is really large and it takes a lot of computing power. So that is something that needs to be taken into consideration. So how you define yourself, how much data you want to retain. So if that those large models are not needed, then you could use smaller embedding layers such as the Glover or something, which are not that big and which are not that hard to process. But it can become a really large model.
Okay, thank you. So basically, Lucia, I would like to thank you once again for your time and for delivering such a outstanding talk. It was nice and it was pleasant to listen to you. With this, we are coming to the conclusion, recap of the day.